Hello everyone, I hope you guys now have a decent idea about what is a linked list and how we can iterate over a linked list. So in the last few videos we wrote this very simple code. We created the class node and then we write the print function. So if we'll see the print function, what we are doing here is, so we are taking head by reference. Actually we should take head by value. Okay, so I will change this. We will take input by value and then we are just printing the data and then move forward, and finally we are printing null. And then what we are doing, so here if you notice we are creating the node statically. Okay, so we are creating the nodes statically. So this is all that we have done in the past few videos. Now let us update this code. We will call the print function only once and not twice. Okay, and instead of using head, what we will do, we will take a temporary pointer which will point towards the head, and we will take the help of that temporary pointer. Okay, so let's do all these changes. So what you want to do here is, first of all we will take the linked list by value. We will take head by value and not by reference. Secondly, if you want to iterate over a linked list, it is a good practice that you create a temporary pointer. So this temporary pointer will initially point towards the head of the linked list, and then we will iterate over the linked list with the help of this temporary pointer. Okay, so print the data and now we will move forward. Temp equals next of temp. Okay, and we will call print function only once. Simple. Okay, so in this video what we want to do is, so here we are creating the node statically and then we are creating the linked list by doing something like this. Okay, so what we are doing, we are connecting the node by ourselves. So the problem with this is, basically if you want to create, let's say, a linked list of 100 nodes, then it is not possible for us to connect all the 100 nodes in this manner. So what we want to do is, we want to create a function. Let's say the name of the function is take input. So I want to create a function take input. So what this take input function will do, it will take the input from the user, it will create linked list, and it will return the head of the linked list. It will return the head of the linked list to main. Okay, so if you know the head of the linked list, you basically know the complete linked list. So this function will return me the head of the linked list, that we will create. Okay, simple. So let's write the code for this take input function. Okay, so let's do this. So I want to create a function take input. So what will be the return type? So I want to return the head of the linked list. So the return type will be node star. Okay, I want to return the head of the linked list. So node star, the name of the function is take input. Now what it will take as parameter? So it will not take anything as parameter. Now the question is how to take input from the user. Okay, so how should we take input from the user? So if you remember in arrays, what we used, how we used to take input, so we do something like this: int n, c in n. What is n? N is basically the size of the array, how many elements you want to insert, and then basically with the help of for loop, I equals 0, I less than n, and I plus plus, we used to do something like this: c in a of I, where a is the array. So in array we used to do something like this, but we cannot do something like this in linked list. Why? Because linked list says the number of elements you don't know. Okay, so this thing is valid for array. First you have to take how many elements, and then basically you run a for loop and you take input. But in linked list there is no constraint of size. Okay, so we do not have any constraint on size. User can give as much number of elements as user want, and we have to create linked list with the help of those elements. Simple. So the problem arises, how do we take input? How to write the code for this take input function? Okay, so what I am planning to do here is, for example, user will give me input like this: 1, then let's say 2, 3, 4, and I will create the linked list. So this is the data, 1, 2, 3, 4 is the data given by the user, and I will create linked list in this fashion: 1, 2, 3, and 4. Now as soon as the user gives me, let's say 5, then I will link these two nodes. User give me input 6, I will create this node, I will create this connection. Now as soon as the user give input -1, as soon as the user give input -1, so I'm going to use -1 as my termination, as my terminator. Okay, so what will happen? After 6, let's say the user gives me input -1, then I will stop. I will stop taking input and this will be my linked list. Okay, so suppose this is the input given by the user, 10, then let's say 12, then let's say 13, 24 and -1. So let's say this is the input given by the user, then my linked list should look like this: 10, 12, 13 and 24. Okay, so I'm going to use -1 as my termination criteria. So this will be my linked list if the input given by the user is this. Okay, simple. So let's do this. Why I'm using -1 as my termination? So that the code of the take input function becomes simpler. Okay. Now the disadvantage of using this approach is basically we will not be able to store -1 in my linked list. Okay, so this is the only disadvantage of using -1 as the terminator, that we won't be able to store -1 in our linked list. So let's write the code. Okay. So what we want to do here is, let's take a variable int data. We will take data from the user. Now while data is not equals to -1. Okay, so I'm using -1 as my terminator. Then what we will do, so we will write the code for creating linked list. And what we will do here, so we will take data again from the user. And finally what we will do, so I will return the head of my linked list. Simple. So for returning the head, let us create head. So node star head. So currently my linked list is empty. So if the linked list is empty, so head is pointing towards null. So this means your linked list is actually empty. Okay, so initially my head is pointing towards null. Okay, so let us take tail pointer also. So node star tail. So tail will point towards the last node of my linked list. So currently my linked list is empty. So that's why tail and head both will point towards null. Simple. Okay, so this also means if tail is pointing towards null, that means my linked list is empty at this point. Okay, so what I want to do, so I want to create linked list. So for creating the linked list, you can see first what we have to do. So we have to create nodes. Okay, we have to create nodes first. So how do we create nodes? So I will do something like this: node n and data. Okay, now my question is, so is this syntax correct or not? We should create nodes statically or we should create nodes dynamically. So suppose the input given by the user is 1, then 2, then let's say 30, 45 and -1. So this is the input given by the user. Okay, so we will store this input in data variable. Now what we are doing, so head and tail, they both are null because my linked list is currently empty. Then what I am doing, so I am creating a node statically. Okay, we are creating the nodes statically. So what will happen at this point when the data is 1, I am creating the node statically. So 1 and the next pointer is null. So this is my node. Okay, then I am not doing anything. Then I am taking data again. So this time my data is 2. Okay, so this is my data. The data is 2. Then what will happen? So I will again check the condition. So data is 2, 2 is not equals to -1. Then what will happen? This node will get away. It will be deleted. Why it will be deleted? Because this is statically. We are allocating memory statically and the scope of the static memory is only for one iteration. Okay, so this node is valid only for one iteration. For the next iteration, what we will do? So we'll again create the node. We will again create the node 2 and null. Then we will again take the input. So the data is, this time the data is 30. Then we will check. So 30 is not equals to -1 and this node will be deleted from the memory. Why it will be deleted? Because we are allocating memory, we are creating nodes statically. Okay, so that is the problem. if you are creating something statically, then the scope is between this bracket and this curly bracket. Okay, the scope for the static variables are only for one iteration. So one thing is very clear here, that we have to use dynamic memory allocation. Okay, so if you will use dynamic memory allocation, then the nodes will not be deleted when it goes out of scope. The nodes can only be deleted with the help of the delete keyword. Okay, so let's create the node dynamically. I hope you understand why we are creating the nodes dynamically and why we cannot create the nodes statically. Okay, so what is the syntax for creating the nodes dynamically? So the syntax is very simple. What we will do, so we have to do something like this. Node star n is basically, we have to use new keyword, new node, and we will give data. Why data? Because we have to call the parameterize constructor. You can see we are calling the parameterize constructor here. Okay, so after creating the node, what we have to do? So we have to check whether this node is the first node. First of all, we have to check whether this node is the first node, and how we will check? We will check it with the help of head. So if head is pointing towards null, that means this is the first node of my linked list. So if this is the first node of my linked list, my head will get updated. So head will point towards n, and also since my linked list is currently containing only one node, so tail will also point towards n. Okay, so head and tail will point towards the node that we have created. Okay, so if this is not the first node, in the else part, this is not the first node. That means I have already some nodes in my linked list. Okay, so what I am trying to do here is, let's say my linked list is already containing, let's say 3 nodes, and the data is, let's say 1, 2 and 3. This is my linked list. Okay, now what I want to do, so this is, let's say my data is, let's say 1, 2, 3, 4, 5 and -1. Let's say this is my data. Okay, so I have already processed these 3. Now time to process this data, and this is my head. Okay, so head will point towards the first node, and this is my tail. Tail will point towards the last node of the linked list. Okay, so what we will do, I will create a node with the help of the data. Data is 4. Okay, so let's create a node. This is my node. Data is 4. Then I will check this condition. If head equals null, no, head is not null. Head is pointing towards the first node. Then in the else part, what we have to do, so we have to make this connection. Okay, so this node is n. You can see this node is n, node star n. So we have to make this connection. Now how do we make this connection? So this is very simple. I have to write like this. The next of tail is n. Okay, so this is my tail node. This is my node n. We have, if we will write the syntax, next of tail equals n, then this connection will be established. And then what we have to do, we have to update our tail pointer. So tail will point towards this because this is the last node. Okay, so tail will be updated. So you can write tail equals n. Okay, we have to update the tail, or you can also write instead of this line, but you can also do tail equals next of tail. Okay, tail equals next of tail. So both these two lines are same. You can use any one of them. Okay, so we have to write these two lines. So let us write these two lines. So what we have to do here is, I am inserting the node at the last. So next of tail equals n. Simple. And then we have to update tail. So tail equals n. I think this code will work. Okay, so let's dry run this code and then we will try to run our code. Okay, so let's say for now this is my data. So data is only, let's say 10 and -1. This is the data given by the user. Okay, so head is initially null, tail is null. So this is my head, this is my tail. Okay, so what is the value of head? Head is pointing towards null and tail is also pointing towards null. Perfectly fine. And this is the value of data. So data is currently 10. Okay, we are taking the input. Now check. So 10 is not equals to -1. Yes, this condition is true. Now go inside the loop, create a node n with this data. Okay, so I am creating a node n. So node n, and what is the data? So 10 and null. and let's say its address is 100. So 100 will be stored here. Okay. Now what we are doing, so I am checking whether this node is the first node. Head equals null. Yes, head is null. That means this node is the first node. Okay. So if this is the first node, I am updating head and tail. So head and tail will get updated. Head will point towards 100 because head is pointing towards n. Okay. Head is pointing towards n, tail is pointing towards n. So head and tail both will get updated. 100 and 100. 100 is the address of this node. Okay. We are dynamically creating nodes. So this is heap memory. Okay. This is heap memory. Then we will again take input from the user. So again take input. This time the input is -1. Now check. -1 is not equals to -1. So the condition is false and I am returning head. We are returning head and head is containing 100. So I am returning 100 and that is correct. Okay. So what is my linked list? My linked list is only this 10. This is null. Head is pointing towards this node and tail is also pointing towards this node because my linked list is of size 1. Okay. Now in the second part, let's say this time my data is different. So let's say the data is, let's say 10, then 12, let's say 40, and let's say -1. So if this is the data, this is my head, this is my tail pointer, this is data, and this is n. Okay. So initially you can see, so data is initially 10. So data is initially 10. Head and tail, they both are null. So head is null. Tail is also null. Fine. Check. So data is 10. 10 is not equals to -1. True. Create a node dynamically. So create a node. So create a node dynamically. So 10 and null. Let's say address is 10, or let's say the address is 100. So n. So n is basically in the stack memory. Okay. So n is in the stack memory. So n is 100. Now check for the first node. Is this the first node? If it is the first node, so head equals null. Yes, this is the first node. Then update the head as well as tail. So head will get updated 100 and tail will get updated 100. So by 100, this means the head is pointing towards this node and tail is also pointing towards this node. Simple. Then take the data again. So this time the data is 12. Okay, so update the data. Now the data is 12. So check the condition. 12 is not equals to -1. True. Create a node dynamically. Now see, the n was static. So what will happen? This n will be destroyed because its scope is only for one iteration. So n will be created again. Now this time, so create this node 12. So 12 and null. Let's say the address is 120. So n will be created again. Now it is containing 120. Okay. So this condition is false because this is not the first node. So I am inserting the node at tail. So tail arrow next is n. So tail, this is the tail. Okay. So this is the tail. And what we are doing, so tail arrow next is equals to n. N is containing 120. So this is 120. So instead of null, 120 will come here. Simple. And tail will get updated to n. So basically this is my tail now. And remove tail from here. Okay. Now the data is 40. Okay. So data will get updated to 40. Now check this condition. So 40 is not equals to -1. True. Again create. So this n will be destroyed again and this n will be created again. Now this time the node is 40. So I have 40 and null. Let's say the address is 420. So n will store 420. Simple. Now what we are doing, so check this condition is false. This is not the first node. So if this is not the first node, insert the node at the tail. So tail arrow next of tail is n. So next of tail is n. N is containing 420. Okay, so this null will be replaced by 420. And then move tail ahead. So remove tail from here and now this is my tail. Simple. Okay, so this time the data is -1. Okay, we are taking data again. So data is -1. Now check the condition. So -1 not equals to -1, the condition is false. If the condition is false, I am returning head, and head is pointing towards the first node of the linked list, so I am going to return the address of the first node, which is 100, and this is my linked list. 10, then 12, and then 40. Tail is here and my head is here. So I think everything is working fine. Okay, so our code will work absolutely fine. Now let's consider one last case. So this time the data is only -1. Data is only -1. So data is -1, head is null, tail is null because the linked list is empty. -1 is not equals to -1, the condition is false, and I am returning head. So head means I am returning null. Okay, head is pointing towards null, so I am returning null. Null means your linked list is empty. So I think our code will work for every case. Our code is handling every corner case. So let us try to execute our code. Okay. So for executing our code, we have to call this function take input. And now let us comment out everything. Okay, so I have to call the function. So it will return me the head, node star head, and I will call the function take input. Okay, so what we are doing here, I am calling the function take input, and then this take input function will return me the head of the linked list, and I am calling the print function and I am passing head. So basically we are printing the linked list also. Okay, so let's test our program whether it is working or not. So let's say my data is 10, 23, 45, 78, 14 and -1. Okay, so this is my linked list. You can see 10, then 23, 45, 78, 14 and null. So this is my linked list. So basically our code is working fine. Let's test for one or two more cases. Let's say my input is 1, 2 and -1. So 1, 2 and null. Our linked list is working perfectly fine. Now let's say my data is only 10 and then -1. So my linked list is containing only one node, 10. And let's say my data is -1 only. So that means my linked list is empty. So that's why null is getting printed. Okay. So our code is working perfectly fine. Now in this case, what we are doing, so we are basically inserting at tail. Okay, we are inserting at tail. So why I'm telling you that we are inserting at tail, because suppose this is your linked list 1, 2, 3 and 4. Suppose this is your linked list. Okay, this is your head and this is your tail, and suppose the data is 5. Okay, so if the data is 5, you will create a node with the data 5. Now you have two options. First option is you can insert at tail. So if you will insert at tail, the scenario will be like this. You are inserting at tail and then basically you will update your tail. So this is your new tail. So that's why I am telling you that we are inserting at tail. Now there is one more way what we can do. So instead of inserting at tail, what we can do, we can insert at head also. So what we will do, so this node is n, this node was n. So what we can do, we can insert at head also instead of inserting at tail. So we can insert at head also. So what we can do, so create a node and we will insert, and then we will basically update our head. So our head will come here. Okay, so we can insert at head and we can insert at tail. In this code we are inserting at tail. Okay, so let's discuss what is the time complexity of our code. So suppose, so this work is basically constant. This work is also constant. We are doing constant amount of work, and this is also constant. So basically for one iteration the work done is constant. Now if you want to insert n nodes, and for inserting one node we are doing constant amount of work. Okay, we are just changing pointer. For example, if you want to insert at tail, what you have to do, you have to just create one node, then basically you have to connect the tail node and this newly created node, and then you have to update the tail. So basically we are doing constant amount of work. And so for one node, you are doing constant amount of work. For n nodes, how much work you will do? You will do nk work. And what is the time complexity? Time complexity is big O of n, where n is the total number of nodes to be inserted in the linked list. Okay, so this is the time complexity of this function. Simple. Now your homework is basically you have to change this code. I am inserting at tail. Basically you have to insert at head. Okay, so basically what you have to do, so what this code is doing, so if the data is 1, 3, 7, 10 and -1, so if the data is this, if this is the data given by the user, so this code is creating linked list in this manner: 1, then 3, then 7, then 10. This is your head and this is your tail. So this code, this take input function, is creating this linked list, this type of linked list, and then we are returning the head. Now what I want you guys should do, so you have to create the linked list in this fashion. So if the data is 1, so the linked list should look something like this: 1, 3, 7 and 10. So 10 is pointing towards 7, 7 is pointing towards 3, 3 is pointing towards 1, and then basically you will return the head. So this is head and this is tail. Okay, so the only difference is very simple. Here I am inserting at tail. Okay, here I am inserting at tail. In this code, what you guys will do, you will insert at head. Okay, so for example, data is 1, so create node with the data 1. Now the data is 3, so you will create node 3. This is your head, so you will make this connection and you will update your head. Then the data is 7, you will create the node 7, you will make this connection and you will update your head. Now the data is 10, so again you will create a node 10, you will make this connection, you will update your head. And finally the data is -1, so you will not do anything, and initially when you updated your head, you will also update your tail. So tail will not change. Okay, so this will be your tail and this will be your head. Okay, so you have to do very minor changes. Okay, so I hope you guys can do it. In the next video I will write the code for inserting at head. Okay, in the next video I will write the code for inserting at head, but I want that you guys should do it yourself. Okay, so I will see you in the next video. Bye bye.